Welcome everyone to Road to Web3 Week 3. My name's Hardhat, and this week I'm going to be showing you how to build your own on-chain dynamic NFT. First of all, who am I? Like I said, I'm Hardhat. I'm a developer advocate over at Polygon. Previously, I've been a front-end engineer and Solidity engineer, been an indie hacker, and still a Web3 enthusiast. These are some places you can find me on Twitter, LinkedIn, and GitHub. But let's not make this about me. We're going to be talking today about on-chain NFTs. What exactly are on-chain NFTs? I've got 3 examples of them up here on the screen. One is my developer DAO DeFi Revolution NFT. One is a corruptions NFT. And this is one of my personal favorite ones, a flipmap NFT. What are so cool about these NFTs? See, the metadata is not hosted on a protocol or service like IPFS or Arweave. They're all actually on-chain. Metadata URIs are built using data URLs, which we're going to be exploring in just a second. And the images and JSON objects are represented by base64 encoded strings. We're also going to be exploring that in just a second. And like I said before, all of this data is stored completely on-chain. So let's take a look at some SVG code. So this very, very long piece of code is the SVG code that represents the flip map I showed you before. I know, it's a lot. We don't need to know too much about this stuff. But the thing is, SVG code can't be used inside of Solidity. So we need to figure out a way to use this. What we can use in Solidity are strings. So I'm going to go to this online utility that converts my SVG input into what's called a base64 encoded string. So we hit encode, and now we go from this gigantic SVG to this gigantic alphanumeric string of characters that essentially represent data that boils down to become this. So how does that actually help us? If we go to this browser, you see I've started to type out a URL here, but the URL is a little bit different than what you might be used to. I start with the word data, then I'm specifying that this is going to be an image/SVG, this is going to be an XML file, and we're going to be using base64 encoding. So if I go back here, let's take this entire string. We're going to copy and paste that into the browser right after that comma, hit enter, and boom. Now I have a URL that resolves to an SVG. I didn't have to upload this to IPFS. I didn't have to upload this to Arweave. I didn't have to use any type of cloud provider or anything. It's not hosted anywhere. This is just a giant string of data in the form of a URL that represents this SVG. So now we kind of know how we can use images inside of our Solidity code. The same thing applies to JSON objects. And I'll show you that once we go dive into the code. So what's next? Some issues with on-chain NFTs. You see, with on-chain NFTs, smart contracts are going to need some additional functionality to handle generating them, right? Taking that bunch of different strings that represent SVGs and a bunch of different strings that represent JSONs and converting them into, your base64 can add some complexity. And depending on how complex your NFT is, you can end up saving a whole lot of data on the blockchain. And this is going to get very costly. So how do we have these cool, dynamic on-chain NFTs, but still save on costs? That's where Polygon comes in. Polygon is the leading platform for Ethereum scaling and infrastructure development. We provide different L2 solutions like ZK rollups, optimistic rollups, we have sidechains, hybrid solutions, and more. Today, we're going to be mainly focusing on the proof-of-stake blockchain. The proof-of-stake blockchain is an EVM-compatible blockchain, meaning everything that you've already been building for the past couple of weeks, all of the Solidity you've been learning, tools like Remix, Hardhat, all of that works one-to-one, maps right over to Polygon. Just takes one line of configuration. Our native token is Matic, and we're very accessible and sustainable, and I'm going to show you why. So why should you build with the proof-of-stake blockchain? First of all, speed. 65,000 transactions per second. Pretty fast, right? And you can still leverage Ethereum in your dApps. You can conduct transactions on the proof of stake chain, bridge your assets back to Ethereum, back and forth. So, do all your calculations, do all your, utility for your NFTs on a proof of stake chain like Polygon, and then bridge it back to Ethereum for, the final layer of, or the, moment of truth of wherever you want your NFT to be. You also save on costs, It's approximately 10,000 times lower cost per transaction than Ethereum. When I first started learning how to build smart contracts, I tried to deploy a smart contract in the middle of several high-profile NFT drops. The gas costs were extremely high, and it was pretty inaccessible for me to be able to spend a whole bunch of money to put essentially a toy smart contract out into the world on the mainnet. With something like Polygon, I probably could have done that at a fraction of the cost. So to get everything set up and to get you starting to code, let's set up our wallet to be able to handle connecting to the Polygon network. I'm going to head over to Polygonscan.com. I've already got my MetaMask wallet set up. Right now it's on the Ethereum mainnet. On Polygonscan.com, if you just go right to the bottom, hit Add Polygon Network, your MetaMask will pop up, and you can simply approve this, hit Switch Network, and boom, you're all set. You're already connected to the Matic network through MetaMask. Now, this is great if I want to actually put anything out on the mainnet for Polygon, but we're going to be testing things out on the testnet. You can go to mumbai.polygonscan.com. Once again, scroll down to the bottom, add the Mumbai network, which is our testnet, hit approve, switch network, and boom. Now we're on the Polygon testnet for MetaMask. Great. Now that we're on the testnet, we also need to get some Matic, some test Matic. So we're going to go to faucet.polygon.technology. I've already pasted in my wallet, but you paste in your wallet, select that you want a Matic token on the Mumbai network, hit submit, hit confirm, and within a few minutes, you'll be able to get your Matic tokens. Cool. So now that our wallet is set up, let's dive into a couple of things we need to consider before we dive into the code. There are a couple of complexities with the type of code that we're going to be writing. First of all, we're going to be talking about concatenating strings, specifically using this ABI encode function for concatenating them. Application binary interface is the standard way to interact with contracts in the Ethereum ecosystem. ABI.encodepackt, the API library, gives us this encodepackt function, which is a native function that can take any number of strings and concatenate them together into bytes. Any argument that we supply to ABI.encodepackt must resolve to a string. It only takes strings. I learned that the hard way. Trust me. Now, I mentioned that ABI.encodepackt returns some bytes. What is the bytes? Bytes are a specific type within Solidity. They're usually a group of binary digits or just machine-readable code, and we can convert them back to strings by typecasting, which you'll see in the smart contract once we start writing it. Now, what's the thing that we're actually going to be building? Like I said before, we're building an on-chain NFT, so all of our metadata is going to be hosted on-chain. It's going to be a dynamic NFT, which means it's not just going to be something you can mint it and view it on OpenSea, but based on certain actions that we take on-chain, this NFT is going to update. So it's not always going to remain the same. This NFT is going to be a primitive that you'll be able to use to build an on-chain NFT gaming dApp. You'll see here on the screen, I have this NFT labeled Warrior and another line that keeps track of its levels, which is currently at 1. We're going to create a function that actually increments that level and updates it on the NFT metadata so you can actually view that update on OpenSea. That's awesome, right? The challenge that I'm going to go over at the end of this video is for you to take this and build it out even further, add more functionality on top of it. For now, though, I'm going to give you the primitive that you need to start building your own NFT gaming dApp. Now let's start coding. So let's get started building. In my terminal, I'm going to make a new directory called Chain Battles. I'm going to cd into Chain Battles. I'm going to use npm init-y, which will create a nice little package.json for us. And from here, I'm going to start using yarn, but you can use npm as well. I'm going to do yarn add hardhat just to make sure we have that as a dependency. Once hardhat's installed, I can go ahead and do npx hardhat to initialize a basic sample project. I'm just going to say yes to everything. And I'm also going to add a couple more things for the dependencies as well. And just because I don't want to butcher the spelling of any of these, I'm going to copy and paste these. First, I'm also going to add OpenZeppelin contracts. We're going to be leveraging some of the OpenZeppelin stuff. Huge shout out to OpenZeppelin because we're going to be using a couple of their utilities in this. And we're also going to use this Hardhat Etherscan package, which is going to help us with verifying our contract, which we'll touch on in just a little bit. And this .env package, which is going to help us with protecting some of our environment variables. Cool. So I'm going to go ahead and open that in my editor. I'm using VS Code, but you can use whatever you want. Let me maximize this so you guys can see it. And I'm just going to kill the greeter contract that comes in here, move that to trash. Also get rid of the sample script. And I'm going to change the Hardhat.config. I'm going to copy and paste one that I had written before. And I will explain in just a second what this does. First, I'm requiring that .env config, which will go into a .env file, which is going to have some of my environment variables, which we'll get later. The rest is just, the Hardhat waffle regular stuff, as well as this Hardhat Etherscan. And here I'm just like mentioning what Solidity version I want. I'm going to be deploying to the Mumbai network. So this should not be mainnet RPC. This should be testnet RPC, but same thing. Testnet RPC. We're going to get an RPC over from our friends at Alchemy. And the last thing we're going to need is a private key, which we'll export from our wallet. And lastly, even though this says Etherscan for the object, this is fully compatible with Polygonscan. So we're going to create an account on Polygonscan and grab an API key, which is going to help us verify our contract on the blockchain so that we can actually directly interface with a contract from Polygonscan. Very similar interface to Etherscan if you've ever interacted with a contract there. Works very much the same way. I'll save this for now, and we'll just come back to this later. But I'm going to create a new contract called Chain Battles.sol. I'm going to copy and paste a few dependencies because, again, I don't want to misspell anything. So what is all this stuff? First, I'm just specifying that this is under an MIT license. Anyone can use it. Specifying my Solidity version. And I'm importing a bunch of contracts from OpenZeppelin. First, ERC721 URI storage, which we're going to use to mint our NFT. Counters for adding some token IDs. This strings utility, which is going to help us do some cool things like converting integers over to strings, which is going to be very helpful when we're doing our dynamic SVG. As well as this base64 utility, which we'll touch on in a little bit, but this is what's going to help us really work with our SVGs and essentially create like this really cool long alphanumeric string that basically represents a whole image. And we'll take a look at that in depth in just a bit. For now, let's go ahead and start our contract. I'm going to call it Chain Battles. I'm going to say that it is an ERC721 storage, URI storage, rather. And that just means we're inheriting from the ERC721 standard. We're going to be using strings for unsigned integer 256. And this essentially gives our unsigned integer superpowers like being able to easily convert to strings. We're also going to be using counters for counters. And this is going to help us with creating token IDs. So we're going to do counter, which is a private token ID. I'm going to create a mapping, which we'll come back to in just a little bit. But this mapping is going to be mapping to a key and it's basically like a hash map. You're mapping two key value pairs together. So this is going to be an unsigned integer 256, which maps to another one. And this is going to be a public variable, and we're going to call this token ID to levels. This is going to be helpful for keeping track of the levels for each of our NFTs. More on that later. For now, let's go ahead and create our constructor. It doesn't really need to do much, but we do need to call the ERC721 constructor here. ERC721 takes two variables, so we'll call it chain battle, which is going to be the name of our contract, and we'll say cdub chain battles, I guess. Not very good at coming up with those acronym stuff. But nothing really needs to go inside the constructor. We're not going to be doing much there. For now, let's start off by generating an SVG. Now, generally, SVGs are not something you can directly create inside of Solidity code, but we're going to be using a library called abi.encoded.pact, which lets us essentially concatenate strings together. So it's going to look really wild at first, but I'll break it down for you in just a second. So I'm going to call this function generate character, which is going to generate our character NFT. It's going to take an unsigned integer, which will be our token ID. It's going to be public, and it's going to return a string in memory, which means we don't want to save the string anywhere. It's just going to, Solidity is just going to remember this string for the duration of this function call. Now, next thing we're going to do in here is use this bytes type. Bytes is also going to be saved in memory. And this is where we're going to be constructing our SVG. We're going to use the abi.encode.pact, which is going to take an argument or several arguments of strings, turn them into bytes, which we can supply over to our base64 utility up here. So I'm just going to copy and paste these lines because there is no way that I'm going to be able to type all this stuff out without some typos. So let me break this down for you. This is just an SVG code. Just have some styling mapped up over here. The part that you'll probably care most about is this text. Our character is going to be a warrior. And rather than wins, we're just going to keep track of levels. During a test, I had wins, but I think levels makes more sense. So levels, we're going to create a getLevels function, which will take a token ID and return to us some levels from this mapping over here. But essentially, we'll have our warrior, we'll have a level for our warrior, and what we're going to be doing is introducing a function which changes this level every once in a while so that you can actually see a changing NFT, a dynamic NFT that will be tracked for you on-chain and viewable on OpenSea. So now we want to return a string. We're going to be typecasting this abi.encode.pact, which always returns some bytes. ABI.encode-packed. And what we're supplying in here is going to be this data image slash SVG. Actually, let me copy and paste that too, because I will never in my life be able to write that without a typo. But this is what we were looking at before, that data URI image that essentially we put into our browser, and we saw like an image of an SVG. This is what's actually going to be creating that for us dynamically. Instead of going to a website and converting it ourselves, opens up and gives us this base64 smart contract, and we can use base64.encode to take that SVG code and turn it into a nice long base64 string. Awesome. So now our generate character is all set and ready to go. Next, I want to actually create this getLevels function. So another function called getLevels. Also going to take an unsigned integer, just a token ID. This will be a public function. It's going to be a view, which means we'll be able to just view and return something. It'll return a string in memory. We're going to get an unsigned integer called levels, and that's going to be token ID to levels. Let me make sure I spelled that the same way as up here. I had that issue many times, so let's just not tempt fate. And we're going to search for the key with that token ID that we supply to this function. And that is just going to return our levels.toString, which is that nice functionality we get using this strings for unsigned integer 256. We can just simply call this toString function now, and it'll automatically convert that number over to a string for us. We need this to be a string because the ABI.encode-packed arguments must always resolve to strings. I learned that the hard way. Trust me, it was very difficult figuring that out. Wonderful. Now we're going to go ahead and create our token URI, the piece de resistance that allows OpenSea to know what it is we're minting. Now this is a fairly long function, so once again, I'm not going to tempt fate, and I'm just going to drop this in here real quick. Initially call this chain wars, so I'm just going to update this to be chain battles. Battles on chain. Awesome. So this is a function called getTokenURI. Once again, it's going to take a token ID, be public. It's going to return a string in memory. Similar to how we were constructing the SVG up here, now we're going to construct a JSON object. So I'm going to call this bytes, saved in memory, data URI. Once again, using this ABI encode-packed, we're going to create this JSON object, which is really, if you look at it, just a series of strings concatenated together. This is not one of my favorite parts of Solidity. I wish it took JSON objects a little bit more nicely. But what we're going to do is the name of this chain battles is going to be called chain battles, and then we're going to give it the token ID. And because that token ID is an unsigned integer, we can once again use our toString functionality, and that'll be resolved as a string. So the title would be whatever the token ID is. You can play around and give this whatever description you want. That's not a huge deal. And then in the image, we're going to be generating our character, passing it that token ID, and it'll generate us this nice little SVG, which will be displayed on OpenSea. I initially had some debugging going on, but we don't need to put this in here for now. And we're just, once again, going to return a string. We're typecasting this ABI.encode-packed return. And Before, we were doing that data image. This time we're doing a data application JSON. And same thing, we're using the base64.encode and passing it this data URI. Wonderful. Next up, let's create our mint function. Mint function is going to be public because we want everyone to be able to mint. First thing we're going to do is take our token ID and increment it. The reason I'm incrementing it from the start is because the original token ID that you get from counters is 0, and we'll just like start it at 1 just for the sake of recollection. Next, I'm going to have an unsigned integer, which is going to be called new item ID. And we're just going to grab whatever the current value of our token ID is. Now we're going to call this saveMint function. We're going to pass it the message.sender. So message.sender is whoever is currently interacting with this contract. So after that, we're also going to pass it the new item ID. These are the two arguments that we need to make sure we give for this to work. Next, we're going to do this token ID to levels. And once again, just to not tempt fate as much as possible, I'm going to go into this mapping and I'm going to create a new value for new item ID. Just make sure this is spelled the same way. And I'm going to set it to 0. You know, right when you're created, we'll start you at level 0. We're going to set token URI. This is given to us from the ERC 721 standard. We're going to pass it the new item ID. And we're going to get our token URI by also passing that the new item ID. This is going to return to us that nice base 64 encoded data URI. And that's really the entirety of our mint function. Next up is what I believe to be the coolest part of this entire thing. I'm going to create a function called train. Train is going to take a token ID, will be public, and this is where we're going to do some like awesome dynamic stuff that is going to actually change the NFT that we're interacting with. There's two things I want to make sure that we check before we actually allow people to use this train function. First, I'm going to use this require statement. Require takes some condition, and as long as you meet that condition, you'll be able to continue. First thing, we're going to check if the token ID being supplied exists. We don't really want to try to attempt to, you know, do anything to a non-existent token ID. Please use an existing token. So this require statement is first going to check if this token ID exists for this contract. If it does, great. It'll skip this little message here and continue, or it'll display this image as an error message. I'm also going to check one more thing. I want to make sure that the owner of this token ID equals message.sender. I don't want anyone to be able to train anyone else's token. I only want the person who owns the token to be able to train. And the error message you'll get here is you must own this token to train it. Cool. So as long as these two conditions are met, we're going to continue along with our code. We'll create an unsigned integer called current wins. And we'll get that from, well, not current wins, sorry, current level. And we'll get that from token ID. Let's get that from here. And not the new item ID, the current token ID. So we're basically going into the mapping that we have, looking up the current token ID that we passed here, and grabbing whatever the current level is. Once we have that, now we're going to update the token ID to levels. By doing current wins +1. I wrote it this way in case you wanted to like play around and do something cool like generating a pseudo random number in place of this. But I'll leave that up to you, and we'll go over that in the challenge as well. Last thing is, you know how we set this token URI with a new item ID? Well, you can do that again with an existing item ID and essentially update the metadata that is associated to this NFT. So let's go ahead and do that. And rather than passing new item ID like we did on line 64, we're just going to pass the token ID that we got in this function. And we're going to get the token URI once again, which will just generate a new token URI, but making sure that we get the new levels. Whoops. Awesome. And that's our code. You know, this is probably one of the more confusing parts. Here and the get token URI. But once you kind of wrap your head around the API.encoded library and understand these are just like concatenating a whole bunch of strings together, it's not too bad. The base64 encoded library also does like a whole bunch of work for us, so we don't have to like manually go in and, you know, find the data application URLs for all of these. But this is it. This is what we need to create this like small little on-chain dynamic NFT game. It's not going to be a full-fledged game. There's definitely more things that you need to do, but this will get you started. So full disclosure, I did go through this and just correct a couple of different spelling errors, but the code itself is essentially the same and unchanged. So now we're going to get ready to deploy this to a testnet. In my .env file, I've got a couple different variables. I'm going to update this testnet RPC variable because we're not using a mainnet one. So I'm going to need a private key, which we'll get from MetaMask, a testnet RPC, which we're going to get from Alchemy, and the Polygonscan API key, which we'll get from Polygon. So take a look at how to do that. First, shout out to Alchemy for this awesome multi-week course. I'm going to create an app. We're just going to call it On-Chain NFT. On-Chain NFT. Make sure we're on the Polygon chain and that we're going to Polygon Mumbai. Hit create app. Hit view details. View key. I'm going to delete this afterwards, so don't try anything funny with this. Copy that. And put that into testnet RPC. Now, so you're going to polygonscan.com. Around here, you'll either be able to open your profile or create an account. I've already got one, so we're going to go here. Then you just click on API keys. I've got a couple here, but if you wanted to create a new one, you would hit add. Give it an app name. And it'll be created for you. I'm going to go ahead and copy that over here. Finally, I'm going to make sure I grab my private key. Add to account details, export private key, type in password. Go ahead and copy this over. And we're all set. We have everything we need to go ahead and begin our deployment. But before we can actually do our deployment, we need to create a script for deploying. So inside of the scripts folder, I'm going to create something called deploy.js. We're going to call the function here main. It's going to be an async function. I'm going to wrap everything inside of a try catch. So what we're going to try to do is create this NFT contract factory. And we're going to await HRE, which is just Hardhat, and that is automatically inserted into here for us. So I don't know why I did all that. HRE dot ethers dot get contract factory. And that's going to be the name of our contract, which is Chain Battles. Now that we've got that, we're going to create our contract by awaiting NFT contract.deploy. We need to actually wait for this transaction to finish on the blockchain. So we're going to await NFT contract dot deployed. It's in past tense. If all is good, I'm just going to console log out contract deployed to NFT contract dot address. And if all is good, we'll do process.exit 0, which means everything worked out and we're just exiting this script. But if something happened, we want to know what happened, so we'll just console.log out that error, and that'll come up in our terminal. And we'll do a process.exit 1, which signifies that there was an issue. Wonderful. And now we can just run our main function, and we're good to go. Cool. So now what we can do is run npx hardhat run scripts /deploy.js, and we just need to specify our network, which is going to be Mumbai. Hit enter, let everything do its thing. Ooh, uh-oh. Looks like on line 69, I left an extra little friend. Not a nice friend. Had to put that in there. Okay, let's try that again. And wonderful. We've had ooh, I also forgot to change the name. Quick reason why we compiled 13 Solidity files, even though we only wrote one, is because we're importing a bunch of stuff. But let me update. Oh, I think when I was formatting it, it went to the old name. Chain Battles. Now, finally, this should work. Deploying. Let's go. Yes, contract has been deployed to this address. So I'm going to copy this address. And rather than being on Polygonscan, I'm going to go to mumbai.polygonscan.com. And I'm going to search up this address. Sometimes it takes, just a quick second. Cool. Now we've got that contract creation all set up here. Thing is, we click on contract, we can't really see anything, right? So now what we're going to do is actually verify our contract. So we can do npx hardhat verify -- network Mumbai and drop in. Looks like we have a function that can be restricted to view. It's a warning, so I'm not going to go into it, but everything should still compile. But you can go into function generate character and make sure that that is just view, because it does just like not save anything. So once in a while you'll get this error here. If you do get this error, just try it again. Once we do try it again, and wonderful, we have now successfully submitted the source code for our contract. We're waiting for the verification result. Okay, so after some long waiting, we now have a verified contract. We've got a little check mark. Everybody wants that verified mark. And you can see here, if I open it up, that the code that we wrote is available for view. This is great for having transparency for NFT drops, so people can go in and make sure that your code isn't doing anything malicious. But the other cool thing is we can now directly interface with our contract straight from Polygonscan. This works exactly the same way as it does in Etherscan. But you'll see that there's a whole bunch of functions we actually didn't write, right? That's because the ERC 721 standard gives us a whole bunch of cool stuff that we can work with. For now, let's head over to write contract. I'm going to connect to Web3, which means connecting to my MetaMask. Cool, connected to the right wallet. And I'm going to go ahead and mint an NFT. Hit write. Pay some small amount of gas in Matic, hit confirm. We can view our transaction as it's pending. And once it's actually completed, we'll even be able to view that on OpenSea. So we're going to go to OpenSea. Actually, testnets.opensea.io. And I'm just going to go to one that I minted before. This is like an old version, but we're going to replace this with the contract address here. And now we see, chain battles. Number 1, owned by me. We've got our warrior, levels at 0. Nice. It was minted about a minute ago. So we've got our functionality of minting. Great, wonderful. But remember, this is a dynamic SVG, right? What we can do now is train our token. So we have token number 1. Hit 1 here. Click right. And go ahead and confirm that. View this transaction. Sometimes, before this block is fully mined, it won't show up here. But we should see that here. Yep, this is pending here in my MetaMask. Looks like it was done. And all good. Now, it's not going to show up right away here. We actually have to refresh our metadata. But after you refresh metadata, wait for just a little bit. Hit refresh. Boom! Level now is 1. This is not a static NFT anymore. This is a dynamic, ever-changing NFT. And this is just really one of the more basic implementations of what you can do with dynamic NFTs. Just think of hooking this up to off-chain data, tracking credentials, tracking really anything, and updating your NFT to reflect, different journeys that you take either in real life or just tracking, how things are going on in the world, and updating your NFT to reflect that. There's possibilities are very wide open on what you can build with this type of thing. Awesome. So now we've gone through on-chain NFTs. You've learned how to verify your contract. But what can we do now to further improve this? What can we add here? So here's your challenge for this week. You'll see up here on this mapping, I've just associated a unsigned integer with another unsigned integer, called it token ID to levels. What I want you to do is learn how to map a unsigned integer to a struct. So you're going to have to look up to see what a struct is. But in your struct, what I want you to do is not only to track levels, but track HP, hit points, track strength, speed. Doesn't necessarily need to be these attributes, but hey, have at it. Make sure you spell things correctly, unlike me. I still could not spell that correctly, whatever. But it doesn't necessarily need to be these attributes. Just add a few attributes inside of a struct. And what I want you to do is when minting occurs, so down here, how we're adding this little bit over here. Rather than doing this, you're going to map out a full list of stats to be added to your character. And what I want you to do is figure out how to do pseudo random number generation on chain. Generally, for Solidity, you don't want to do random number generation. You can't actually do full random number generation in Solidity, but there are methods of like pseudo random, and generally they're not the safest way of going about doing things. They can present some security vulnerabilities. In our case, though, with tracking some low stakes stats for this imaginary NFT, it should be fine. And just to give you a little bit of a hint on how to get a pseudo-random number, check out things like Kekak256, as well as using the block.timestamp and block.difficulty to calculate a somewhat random number. In the future, you might learn of other verifiable ways to create random numbers. Services like Chainlink have awesome ways of doing that in a safer way off-chain. But for now, based on what we know, let's create a pseudo-random number and generate numbers for different stats, including levels, HP, strength, and speed, and then update this train functionality rather than adding one to the current level to increment each of those stats as your level increases. This will give you the basis for kind of like how in a Pokemon game, when they level up, each of their stats go up. That's kind of like what I want you to mimic. How would we implement that on chain? I would love to see your implementation of this. Can't wait to see what you do beyond this, because really what I've given you is just like one building block for what could be a very robust game on chain. And the awesome thing is, when you do this on Polygon, even when you send this off to mainnet, you don't have to worry so much about the enormous gas fees associated with putting all of this data onto the blockchain, because everything is a little bit cheaper and a little bit more manageable. So thank you for tuning in to this week's lesson. Can't wait to see where else you go and what else you build.